Camilla is an architect and urban planner who has been working on some very exciting projects related to the future of mobility. So Camilla's talk today is going to be called Buro Happold's Micro-Mobility Street Design Manual, which is a development in the field of transport planning. Camilla is an alumni of the Master in Advanced Architecture. She's from the class of 2016-18, and she gained knowledge of skills to integrate engineering in design and planning there. Currently, Camilla is working in Buro Happold Engineering, and she's based in London, and she serves as a transport mobility planner. Her work involves integrating engineering principles into her design and planning work, enabling her to contribute to a variety of international projects on different scales and with different scopes. So thank you so much for joining us, Camilla, and welcome to the stage.
Hello, everyone. I didn't prepare my notes to be under the sunshine, but I'll do my best to, to remember everything. So, as Matilda introduced, I work at Buro Happold as a transport and mobility planner, and the Micromobility Street Design Manual is the result of a research that was funded by the company to our team, and it's actually, the time we started developing this manual it's quite interesting because it was the middle of the lockdown in 2020. And I'm saying it was an interesting time to start talking about micromobility because streets started to change at that time. There were less cars on the roads. Well, there were less people on the roads in general, but also there was this urge to create more space for social distancing, and people didn't want to take public transport. So they wanted to, the government started thinking, how can we accommodate all these people on more individual modes of transport without bringing them back to using their private car. So they started to reducing car lanes to give them to pedestrians and to cyclists. Obviously, this has changed a bit. We're post-COVID, I guess, now, but the topic is still very relevant. Most of the new urban projects have less and less roads and more public realm, and we can see it in Barcelona as well, in the Superia. And obviously the question raises, and it's how can we properly design these public realm spaces, not only for pedestrians, but also for micromobility. So what I'm gonna talk about today is, first of all, what is micromobility? What the document vision is. Actually, let me start answering the questions. Micromobility is, we define it as those lightweight and small-sized transport modes that are for individuals, but can include also transport modes that are up to 3 people. The document vision is based on 10 pillars, and I'm also going to talk about how we can implement them, how we can implement these micromobility lanes in the current streets, and how we can actually, looking at existing roads, how much space can we take and how we can use that space, and how the streetscape space will change. I'll be talking about the pros and cons of shared lanes versus segregated lanes, and then, is it only about creating lanes? No, of course it's not. It requires much more infrastructure than that. It requires transport hubs, parking, charging stations, etc., etc. So starting with what we define as micromobility. I guess everyone's used to see cycling lanes, but is the bicycle the only micromobility mode that you see out there? I doubt it, especially in Barcelona. There are a lot of e-scooters as well, but also you'd see many other modes that are never really included into planning, and usually they're seen as very bad. You know, they occupy the pavements, they occupy the space for pedestrians because there's no regulation behind where they can go. So one of the aim of this manual is to start including these other modes and understanding what the relation between one and the other is and how they're used differently and by different users. So the vision of the manual is based on 10 pillars. I'm not going to go through each one of them in detail, but micromobility, as I said, is lightweight and small-scaled. It has much more flexible accessibility than any other mode besides pedestrian, besides walking. I don't know if you see them a lot here, but in London, a lot of people started using the Brompton bikes, which are foldable bikes, and you can take them everywhere. One of my colleagues goes to the supermarket, folds it, and then carries it around inside the supermarket and uses the basket to like put his groceries in. So the flexibility of certain micromobility modes is quite important and very interesting. They're also modular. You can add, you can turn a bike into a cargo bike. You can use it to move furniture or move stuff. The range of users can also be wide. There are a lot of elderly people using the little carts, I don't remember what they're called. They're used for delivery services, as I said, as cargo bikes. In London, I'm talking a lot about London because I lived there, so that's my experience of micromobility. But being a massive city, I find it very useful sometimes to cycle to a station, put my bike on the train, and then cycle on the other side. So giving flexibility to take your micromobility mode onto a public transport service increases the range of distance you can use it at. Obviously, the importance of cycling maps and hierarchy, clear hierarchy of routes is quite key in how you can cycle around the city or go around the city with your micromobility mode. Designing junctions to promote the priority of micromobility modes, and also obviously there's a big talk around an autonomous future, and some people say that autonomous micromobility might actually be what's going to change life in the city and will become the main transport mode, but there's obviously a lot of skepticism against it. And then data-driven city planning, so how both the cities from a top-bottom approach and the users from a bottom-top approach can use the data to improve their experience of micromobility in the city. So the methodology that we've used to define this manual and define the micromobility street design starts with modal classification. So micromobility modes can be divided into electric and human-powered, but also a very important distinction is who the user is and what's the purpose of using these modes. So there are commuters which travel longer distances at higher speeds. There are people who use micromobility as a leisure. And then there is servicing, so logistics. And it's quite important to make this distinction, not only because of the speed, but also because these micromobility modes have different sizes as well, which helps us define if we're deciding to integrate a segregated lane, how wide this lane has to be. Yeah, so as I said, there's also always the question of, is it better to have a shared lane or is it better to have segregated lanes? And we've analyzed pros and cons of each one of the options. And obviously, it kind of it's very based on the setting and the project that you're talking about. So there's a lot of talking around this as well. This is a very important point and a bit more of an engineering one. In transport planning and in roads, we measure the capacity of a road in PCU, which is passenger car unit. This unit, basically helps us understand how many people a road can take in an hour, so its maximum capacity. And we've tried to basically create a parallel unit for micromobility modes to understand a certain lane, how many people it can carry. And this was a very interesting exercise, as you will see in the next slides, because we have well, we have looked at the design guidance of the specific lanes, and obviously the importance of hubs, so charging stations, docking station, and also how to integrate micromobility hubs into public transport hubs and creating these multimodal settings where you can easily and seamlessly transition from one mode to the other. But then I guess the most important part for me was the pilot studies that we did. So we took 3 different examples, and we kind of tried to understand what would happen if we take one lane away from cars and give it to micromobility, applying the analysis that we've done. So the 3 examples are the Champs-Élysées in Paris. It's a commercial street and a 2-way boulevard, and it's a very high touristic attraction. So here we're looking more at, you know, tourists which are using micromobility as a sort of like recreational mode rather than a commuting mode. And it's right in the center of the city. The second case study was in London, Camden High Street, which is a highly residential street. And then the third one was in New York, Broadway, which is a major downtown one-way street, and it's probably it's probably mostly used by commuters. So you can see in the diagrams in the center the kind of type of analysis that we were doing, and at the bottom, unfortunately, it's quite small, but basically you can see how much the capacity of the street space increases by changing one lane from private cars to micromobility. And it's kind of crazy, but micromobility lanes have a much, much higher capacity than car lanes. And I guess this was probably the most interesting result we got. This is what we did for Camden High Street. It's a one-way system, but basically the result is very similar. And I guess the interesting part of these 3 different case studies was what would we want to implement in a road that's on one side, Champs-Élysées is very touristic, but Camden High Street is more residential and probably has a lot of logistics micromobility modes. So we were looking at different types of lanes and lane width to understand what's the optimal capacity we can provide for the road. And then the last one is Broadway, which is more for commuting. So we would give a lot of space for micromobility modes that go at a higher speed. And that's it. Thank you.